All right, geometry. We are in the second part of Unit 1. And today we're starting Lesson 6-1, Justifying Statements. So today's going to be a short lesson, but it's very important because it's kind of our introduction to proofs. So what we're going to do today is to use definitions, properties, postulates, and theorems to justify statements so we can start writing two-column proofs. Okay? So make sure you have your Springboard book open to page 63 and something to write with. So let's get started. Okay, so we're getting into proofs in activity 6, which is really important in geometry. Okay, a lot of times people think geometry, they think proofs. So a proof is an argument, a justification, or a reason that something is true. A proof is an answer to the question why. It's when the person asking wants an argument that is indisputable. Okay. So there's 3 basic requirements for constructing a good proof. Awareness and knowledge of the definitions of the terms related to what you're trying to prove. Knowledge and understanding of postulates and previous proven theorems related to what you're trying to prove. And knowledge of basic rules of logic. Okay, so let's look at this picture here that they drew for us. And to write a proof, you must be able to justify statements. So that's what we're going to do here in example A. So what they've given us is just a bunch of statements. They all kind of go back to this picture up here. That's where they're getting all their segments and angles from. But what they're going to do is give us a statement, and we have to supply the justification as to why that statement is true. Okay, so let's look at A. It says angle ABE is a right angle, then measure of angle ABE equals 90 degrees. So what's that justification there? Okay, well, that's the definition of a right angle, right? If something is a right angle, we know it's 90 degrees. So that can be our justification. Okay, let's look at this. If the measure of angle 2 is congruent to the if angle 2 is congruent to angle 1 and angle 1 is congruent to angle 5, then angle 2 is congruent to angle 5. So let's think about what property that's going to be good for. And we haven't actually talked about this one at all, but this is the transitive property. And your book does point this out over here on the right. Okay, but you can apply that for congruence. So what they're saying is if we take angle 2 equal to angle 1 and angle 1 equal to angle 5, angle 1's kind of that middleman there, so we can kind of cross him out and then just put our 2 on the ends congruent to each other. Okay. All right, our next statement says given B is the midpoint of AC, then AB is congruent to BC. So what's our justification to make that statement? That would be the definition of a midpoint. We learned about that in activity 4. Okay, the measure of angle 2 plus the measure of angle ABE is equal to the measure of DBE. So again, we're going back to this picture here. So they're saying the measure of angle 2, okay, plus the measure of ABE, okay, has to be equal to DBE. Well, what's that postulate or, yeah, it's a postulate. What's that postulate we learned in activity 4 that said we can do that? That was our angle addition postulate, remember? So if we have 2 small angles, put them together to make one bigger angle, then we add them together, it's equal to the big angle. And last one, if angle 1 is supplementary to FBE, then measure of angle 1 plus FBE is 180 degrees. Well, our justification there, that's how we define supplementary angles. If 2 angles add up to 180 degrees, then they're supplementary. Okay? So again, make sure if you need to, you can look up these other properties, the reflexive, symmetric, and transitive properties, but we can use those also. Okay, so on the next page, we're going to try this one. Now, it's not filled in for us already, so we're going to have to make our own justifications, but use the diagram and name the property, postulate, or definition that justifies each statement. Okay, so let's look at A. So they have, I'm going to make this bigger so I can see the whole picture and the entire table. So we have EB plus BG is equal to EG. So what's the property that says that we can equal those? Well, hopefully remember that's our segment addition postulate, right? Okay. If the angle 5 is congruent to angle 6, so angle 5 and angle 6, if those are congruent, then they're saying BF bisects the angle EBC. So what lets us make that justification? Well, that's just the definition of an angle bisector. Okay. The measure of angle 1 plus the measure of angle 6 is equal to 90 degrees. Then angle 1 is complementary to angle 6. Well, that's our definition of complementary angles. If two angles sum to 90 degrees, we call them complementary. Okay, so D says that the measure of angle 1 plus the measure of angle 5 is equal to the measure of angle 6 plus the measure of angle 5. Then angle 1 is equal to angle 6. Now your book here put the answers a little something different. They called this the subtraction property of equality. Okay, but on the first page, they also listed the transitive property. So I would take both here. Kind of doing a switcheroo on us. Okay. Okay, and this last statement here says, given that AC is perpendicular to EG, then the angle ABG is a right angle. So what's that justification? Well, that's the definition of perpendicular lines. If something's perpendicular, it implies a right angle. Okay. All right, so let's do a couple more problems on the next page just to kind of solidify this lesson. Let's look at number 1. Number 1 says, explain why the following statement does not need to be justified. So it says the midpoint of a segment is a point on the segment that divides it into two congruent segments. So why do we not need to justify that? Take a second and kind of think about that. Okay, so you should have been thinking something along the lines of a midpoint. Okay, that's the definition of a midpoint right there. If we looked it up, that's the actual definition. So definitions we do not need to justify, okay? Definitions are always true, okay? We take them at face value. So if something is a definition, we do not need to prove it, okay? We use definitions to prove statements that we don't know are true yet, right? Okay, let's look at number 2. It says, given RS and ST share endpoint S. Based on this information, Michaela says that the segment addition postulate justifies that RS plus ST has to equal RT. Is there a flaw in her reasoning? So do you think Michaela is flawed in her reasoning? Yes or no? Okay, I'm going to say that yes, Jessica is flawed. And I'm just going to kind of give a counter example here. What if you had these two segments? So I guess maybe these shouldn't be lines. They should be segments. Maybe I should just do this. Okay. So if something has a common endpoint, these can both have an endpoint, but they are not one collinear line. Okay. So therefore, you can't really do the segment addition postulate on that one. Okay, and the last one, number 3, says write and justify 2 statements based on this figure. So what 2 statements can you come up with about this figure here on the right with angle GFJ? So you could have had other statements, but here's what I came up with. I just said, since we see a little right angle square there, that must mean that GFJ is 90 degrees. Okay. And then also I kind of used a little segment addition postulate, and I said if GFH is added to HFJ, then that has to be equal to the entire angle, GFJ. Okay. So just make sure this little math tip on the side here. We can't always assume in a right angle is 90 degrees just by looking at it. So the only way that you can know that something is 90 degrees is if it's given in the information, or the diagram indicates a right angle symbol, that little square, that means a right angle. Okay, or you somehow prove that the angle is right angle. Okay, so if they give you some kind of justification that leads you to a proof showing that it's a 90-degree angle. Okay. So this lesson kind of just painted the picture for us, okay, to kind of start working our way into proof. So making sure if we have statements that we can make justifications and get those statements proven true. Okay, so in the next video, we will actually start 2-column proofs. So this video is really important just to kind of set that up.